Hi, in this question, we are told that you are sitting in a chair and charge separation between your clothing and the chair puts you at a potential of 200 volts. With the capacitance between you and the chair at 150 picofarad. When you stand up, the increased separation between your body and the chair decreases the capacitance to 10 picofarad. What then is the potential of your body? The potential is reduced over time as the charge on you drains through your body and shoes. You are a capacitor discharging through a resistance. Now this is a typical problem wherein you would have experienced that sometimes you get a shock while touching metal objects or something. So, or high speed cars when they are brought in for refilling, there is a certain modification done to those. So we'll get to that later. Here what we'll do is we'll calculate the charge on the person treating that as a capacitor. Now we know Q is equal to C1 V1 and that will be equal to C2 V2. Since the capacitance has reduced, the voltage has gone up. So V2 is C1 V1 by C2, that is 3000 volts. That was part A. Now that's a very huge voltage. Presuming that you touch something which is 100 volt capacity, then there could be a potential damage to the equipment. So next is resistance. That root is 300 gigaohms. If you touch an electrical component while your potential is greater than 100 volts, you could ruin the component. So how long must you wait until your potential reaches the safe level of 100 volt? Now we know the capacitor discharge equation. Q is equal to Q0 e to the power minus t by tau, which is the time constant RC. So we'll put these values, and then if we take a log on both the sides, we get to see that log of V over V0 will be minus t by RC. So t is going to be, if we cross multiply, t would be RC log V0. V0 is the initial voltage over V, right? And using this we'll find out the time it takes for you to discharge to 100 volts. So our original voltage was 3000 volts. Okay, and resistance is 300 gigaohms, which is 300 to the power 9. Capacitance we have 10 picofarads, 10 into 10 to the power minus 12 into log of 30,000 volts over 100 volts, the desired voltage for you to be potentially safe. Now if we do the numbers here, we arrive at 10 seconds. You can use a calculator or do these calculations from the log table. Log of 3000 over 100 is approximately 3.41 or something. Now next question is, suppose that when you stand up, your potential is 1400 volts and the chair to you capacitance is same, 10 picofarads. What resistance in the wrist strap grounding connection will allow you to discharge to 100 volts in 0.3 seconds, which is less time than you would need to reach for say your computer. So the timing is the constant here, and using the same equation we get to see R is equal to C over T. R would be T over C log of V0 over V. Now that becomes T over C log of V over V0. So we'll put the numbers here. Time expected is 0.3 seconds and we have other values, which is 10 picofarad and log of 1400 over 100, and we work out these numbers. 100 works out to approximately 1.1 into 10 to the power 10 ohm. Now that's a huge resistance required. Thank you. Please subscribe to the channel and keep connected.